All right, so we are going to be taking and multiplying binomials that involve the imaginary number today. So we're going to have to remember part of those powers of I that we talked about a couple of days ago when we get to a little bit further in today's lesson, specifically I squared. Do y'all remember what I squared equals? What kind of one? Negative one. Okay, so we're going to have to keep that in mind when we start multiplying these. But for starters, on both 1 and 2, we have a number in front of our parenthesis and then a binomial in the parentheses. So we're just going to take that number and do what with it? Distribute, right? Multiply it by both terms inside. So I'm going to take that 5 and I'm going to multiply it by that 3. Bless you. That's going to give me 15. Then I'm going to take that 5 and multiply it by that negative 2i, and that's going to give me a negative 10i. Is there anything else that can be done there? No. Okay. So we'll leave it just like that. We're going to distribute that negative 12 to both terms inside the parentheses. So when we multiply, what's negative 12 times 8? Negative 96. And then negative 12 times a positive 3i is a negative 36i. Anything we can do there? Okay. So when we're multiplying, just remember that we cannot leave any powers of I in an answer, like I squared or I to the third or I to the fourth, because we know how to simplify those. Okay? The only kind of I we'll have in there is I to the first. So we ready? Take a minute and write down number 3. We'll work on this one together. Got 2 plus 3i that I am multiplying by 1 minus 4i. When we put all this stuff together for our test next week, remember that we have to pay close attention to if we're supposed to be multiplying or if we're supposed to be adding and subtracting. Here, I don't have anything in between my 2 parentheses. That lets me know that I need to be multiplying or foiling. Bless you. So we're going to start in the beginning, just like we multiply every other pair of binomials. We're going to go the first 2 terms together. We're going to multiply 2 times 1. Then we're going to multiply the outside terms. 2 times negative 4i. Then we're going to multiply the 2 inside terms. A positive 3i times a positive 1 is a positive 3i. And then the outside 2 terms. Positive 3i times negative 4i is going to be a negative 12i what? Squared. Okay, this is where we have to make sure we simplify correctly. I cannot leave the I squared in. I can leave the I to the first, but I cannot leave the I squared. So what I'm going to do is, just to show all my work, I'm going to rewrite the first 3 terms. But what is it that you told me I squared was equal to? Negative 1. So essentially, this is like negative 12 times negative 1, which is going to do what to that 12? Make it a positive. So it's really 2 minus 8i plus 3i, and then just plus 12 without the I involved, because we got rid of the I squared, replaced it with the negative 1 that it is equal to, which just essentially changes the sign of whatever number it's next to. And now, just like we did yesterday with the adding and subtracting, we combine our like terms, starting with the 2 that don't have the imaginary. 2 plus 12 is 14. And then the 2 that do have the imaginary, a negative 8i and a positive 3i is going to be negative 5i. Is there anything else I can do to that? All right. I want you to try 4. Again, we're going to do exactly the same thing we did with number 3. We're going to just multiply each term. -1 times 2 gives me -2. -1 times 2i is a -2i. Positive 4i times 2 is a positive 8i. And positive 4i times positive 2i is a positive 8i squared. But again, we never want to leave I squared in any problem because we know it simplifies to be -1. So I'm going to kind of save a step here. If I multiply the I squared times that 8, what does it turn it into? A -8, okay? Because that's basically 8 times -1, which makes it a -8. And then we can combine our like terms. Two real parts, -2 and -8 give me -10. And then my imaginary parts, a -2i and a positive 8i are going to give me a positive 6i. Is everybody okay with those? All right. I would like for you to try 5 and 6, but with 5, before I let you work on it, it is a binomial squared. What are we supposed to do before we start trying to multiply? Write it twice, right? Exactly the same parenthesis twice. 4 plus 6i times 4 plus 6i, and then you can distribute. Same thing with number 6. You're just going to FOIL just like we did with. I'm going to first of all write this twice. Anytime you have a binomial squared, that's the very first step. And then I'm going to FOIL just like we've done on the first 4 questions. First 2 terms gives me 16. Outside terms gives me a positive 24i. Inside terms also gives me a positive 24i. And the 2 last terms gives me a positive 36i what? Squared. And again, before I can simplify, I have to get rid of that I squared. I cannot ever leave that in an answer. So that's going to be 16 plus 24i plus 24i. But this right here, a positive 36 times I squared, that's positive 36 times -1, which would give me what kind of 36? A negative. We no longer have the I squared because it changed to the -1. And then we can combine our like terms, real parts with real parts. 16 minus 36. If you're not good with adding your integers, use a calculator, okay? You can do 16 minus 36 or 16 plus a -36. Either way, that's going to give us what? -20. And then my imaginary parts, a 24i and 24i add together to give me 48i. Is there anything else I can do with that? Now, 6 is the same, but it looks a little different because my eyes are in different places in each parenthesis. That doesn't change how you do this. We're going to start by multiplying the very first 2 terms. What does -3i times -2 give me? A positive 6i. Then -3i times a positive 3i is going to give me a -9i squared. Okay. Then inside terms, -2 times -2 is a positive 4. And then -2 times a positive 3i is going to give me a -6i. But again, before I start combining my terms, I'm going to get rid of my I squared. Everything else is going to stay the same until then. If I have -9 times I squared, what kind of 9 does that turn it to? Positive. Again, everything else is going to stay the same. Then real part and real part. 9 plus 4 gives me 13. And what do my imaginary parts actually do here? Cancel. Anybody have any questions with that? We got one more. Everybody ready? Sure. I want you to write that down. I'm going to ask you a question before you start working on it, and then I'll let you work on it. Bless you. 3 plus 4i times 3 minus 4i. What do you notice about these? They're conjugates. Remember we did these with radicals where they're exactly the same except for one is a plus and one is a minus? Okay, so we want to remember that these are conjugates. Do you remember what happened to my square roots when we multiplied conjugates with square roots? What did they do? They canceled out. Well, what do you think is going to happen with the imaginary parts here? They're going to cancel out as well. So go ahead and FOIL. When you put your like terms together, because these are conjugates, your imaginary parts should disappear. And you should end up with a positive or negative whole number with no imaginary parts left in it. And we're going to want to keep that in mind because we're going to use that fact tomorrow about the conjugates. Radicals. A lot of the same answers, but I'm also seeing a couple different answers here. Make sure when you're adding, you add correctly. Starting the foiling process, 3 times 3 is 9. 3 times negative 4i is a negative 12i. Positive 4i times 3 is a positive 12i. And a positive 4i times a negative 4i is a negative 16i squared. Again, keeping everything the same for now. And I know a lot of you probably don't write all of this down twice, and that's fine. But what is that I squared going to make that negative 16 turn into? Positive 16. Real part with real part. What is 9 plus 16? 25. I saw some 24s and some 27s along the way. And then my imaginary parts, do they cancel each other out like I said they would? Okay. So what happens is when we multiply a pair of conjugates involving the imaginary number, just like with the radicals, that part disappears, which will help tomorrow when we start dealing with the fractions with imaginary numbers. Anybody have any questions?